Hello everyone, bit of an update on the Mercedes powered lithium ion home battery pack 10 kilowatt. There's another video which is the first one on this series, and if you want to see more about the background and see this thing naked, then you can watch that. It's only a 10-minute video, but it might fill you on some details. Also, there's some inaccurate details in the first section of this series of videos which I need to correct. I said it was 16S battery, or 16 pairs of cells in series, and it was lithium iron phosphate. And in fact, it's a 14S, 14 pairs of cells in series, and it's lithium iron cobalt. The iron cobalt variety you could think as a thoroughbred battery. It's got a higher energy density, probably 40% more power per unit weight than lithium iron phosphate. But it is a bit skittish. You have to look after it more carefully. It can be subject to thermal runaway or catching fire or exploding, whereas the lithium iron phosphate, we thought was an old trucker. It just carries on going. It's much less prone to these faults and is deemed to be much safer. Hence the smoke alarm. Now, what have we got? We've got over here. We've got the Growatt SPA 3000 home storage inverter. We've got the battery terminals down there connected up. The cables come round here, emerge here. There's the positive battery lead bolted onto the battery. The negative battery lead comes up here through a 100 amp 250 volt DC miniature circuit breaker, so that's a current trip, through a marine isolator, battery isolator, through into the Jikong 24S 150 amp balancer, then to the negative terminal. Ignore that plus, that was just a brain fart I had. It's actually the negative terminal, right? And it's mounted onto concrete ceramic board with high temperature paint on it, as if that's going to save me. So looking at the wiring, we've got 0 volts down on this connection. Then each one of these wires goes to a junction on the cells, counting up. So if you measured the voltage on there, between the 0 volts and the first one would be 3.6 volts, and it'd be 7.2, and then on and on and on up to the 14S. I didn't need to buy this one because I thought I needed 16, but you can see I didn't need any of that functionality because I've got a 14S battery. Check what kind of battery you've got is the moral of that story. So in a nominal 48 volt configuration like this is, like I want it to be, then you'd use 14 of these cells in series, these lithium ion cobalt, or basically the old fashioned lithium ion, the standard ones. If this was lithium iron phosphate, you would have a 16S setup because the terminal voltages on the lithium iron phosphate are lower. Alright, but anyway, 14S we've got. Now, as explained before, these two sets of black wires are the thermistors. Measuring, there's one there and one in the centre of the battery pack, and you can set a thermal trip so the battery will shut down, the switch will switch off if the battery gets too discharged. Or conversely, if one cell is overcharged when you're charging, if any of the parameters you set for all the individual batteries go out of bounds, then the power can be switched off, and you can also set a reconnect. If the thing recovers or the temperature drops or the cell voltage comes back into bounds, then you can set it up to reconnect. This is connected by Bluetooth to the app on your phone, and we'll go through all that in detail, okay, in the next video. So that's the balancer, and it's an active balancer, so it will take gulps of current from the battery that's got the highest charge voltage on it and stuff them into the battery that's lagging behind. And I have to say, the balance of this pack is incredible. It's charged it all up, and I thought the balancer wasn't working because it was set to a voltage difference of 10 millivolts, and of course it wasn't charging or wasn't balancing because they weren't out of balance. They're very, very, very well balanced. Incredible. I didn't know what to expect, but it hardly balances at all, but it does balance occasionally. I've seen it doing it, but it doesn't need to. So if we want to demonstrate balancing, we're going to have to set the limit down to 5 millivolts or something like that of the differential between cells, and then it will start balancing and we can demonstrate it. Now when I connected this up, I've got the battery power, battery plus, goes through this 6 amp MCB and a fuse actually in these, there's a couple of fuse holders down here. Just, you know, 6 amps is one thing, but that's really, I'll use that as a convenient switch because I had a DIN rail, but I've put a fuse in circuit as well. And when you switch that on, it just provides the battery plus voltage into here. Alright, so that's the DC power for this thing, but nothing will work. And if you read the instruction leaflet that comes with it, which is around here somewhere, this thing, it does say in there somewhere paragraph, the last sentence in that paragraph is the one that you need to read, apart from it's spelt wrong. I know it's not. They activated the EDs on the end. Charging with a voltage of greater than 5 volts. So what that means is, if you've got no mains and you want to use the emergency power mode on here, say, oh, I've got to turn my gear on because the power's gone off to the mains, you're going to need to apply, you put power on. If I just turn this off now, if I just switch that back on, the B plus will go in there, the battery voltage, but this thing won't react, won't work, won't start up. And it won't start up until it sees a charge voltage. So by a charge voltage, it means it wants to see, before this will start up and communicate or do anything at all, it's a brick at the moment, it needs to see a voltage. That's the battery connection. This is the wire that goes off to the charger and the inverter, so it's the supply lead, if you like. It needs to be a voltage of greater than 5 volts, so this P minus needs to be at a minimum of lower potential of minus 5 volts to B minus, otherwise it won't start. Alright, I mean, you could apply that with a separate mains voltage powered, or mains powered switch mode power supply, but then if the mains are off you can't fire it up. I did think about putting a battery in, and in the end what I found was that I ordered this little box. I'll just take the lid off so you can see what's inside, but it's an isolated DC to DC power supply, and you can put 40 to 135 volts in, which is nice because our battery is roughly about 50 volts most of the time, and you get out 12 volts isolated. By isolated it means there's no DC connection. The only power connection between there and the input side and their output side is the flux in the core of the transformer. So this will produce a 12 volt output when you switch the power on. It takes about a watt, 1.5 watts when it's idling, which is what it's doing most of the time. Now, so where is it connected to? The positive wire, which is the yellow one, goes straight around to here if I had to extend it, and onto the negative battery terminal, and the negative wire, which is the blue one, goes around here through a fuse holder, this thing, and in there, can you imagine, get your imagination switched on, we've got a 2.7k resistor and a blocking diode, a 60 volt half amp, or no, 5 amp blocking diode in a fuse holder. And so that when you power on, this pulls this point down here on the battery, negative lead, down to minus 12 volts. But when this goes below 12 volts, no current will flow back up due to the blocking diode. And then, and only then, can you organise a single switch, which when you hit the switch, it powers up and flashes at you. I don't know why it does that. It's a pain in the arse, frankly. I don't know why you have to apply a charge to get a discharge, if you like, but you do, so I've just gone with it. So I've put this in as a method of having the power, or firing the battery up completely using its own power. Okay, clearly you can't apply any voltage which is referenced to any DC on here, because it has to be 12 volts lower in potential than the actual negative battery lead. So you could have a 12-volt battery or a battery pack or some big capacitors or something. You can press a button to start it, but I just thought I just wanted to flick a switch. And then I'm going to turn the power onto the inverter, and then at some point it'll suddenly realise, you can see the battery meter has gone to full tilt, it's fully charged, and it's going through its startup warm-up sequence now. It's detected that it's got mains and it's got battery power coming in. Now this thing is under test, and I've discovered a few quite alarming things about this, all to do with obfuscation of how much power it uses actually, by crafty reporting. Now I'll go into that in detail next time. It will affect what size battery you put with this, because as you'll find out, it's not quite as it seems. Now we've got this running, it's supposed to be connected to your main supply via a big cable, but I'm running at the moment, I can focus on that focusing thing, you can see it's plugged into a main socket. It's only 3 kilowatts after all, and the current clamp, that current clamp is, the tension of that current clamp on there is to monitor the power. That would be normally located right next to your power meter from your supplier, monitoring the power flowing in and out of your house. But at the moment it's monitoring its own power flowing in and out of a distribution plug lead there. So I can plug things in there and simulate loads on the house and see how this reacts. It works okay, it's been going for a couple of weeks. Now, normally on the Growatt, there's plenty of these inverters around, they're very fairly priced. You can't get the batteries. The Growatt batteries like hen's teeth, so no one will sell you the inverters without the battery. And you can't get the batteries because there's a worldwide shortage of batteries, the 6.5 kilowatt. If you want to see those, look in the previous video because you can see the actual installation. I've got one of these set up with 13 kilowatts of batteries on it already. So out of there is a CAN bus connection. You can see it says CAN in the middle there, CAN the CAN. Got it? That would normally be connected to the batteries, and that interface is used to actually interrogate the batteries. You know, how you're doing, are you happy? Can I give you a bit of charge? You know, what percentage do you think you've got? Can I have some power? Oh dear. Or the battery can say, bloody hell, I'm hot, I'm to turn myself off, and it can raise an alarm on there. So a very simple protocol. I don't think it exchanged all things like, oh, I've got so many cells, this, that and the other, and this is, I don't think there's that much level of diagnostic information, although I don't know, because the old, as far as I can tell, and if you know different, let me know, is the old standalone inverters that just have solar powers and batteries but aren't connected to the grid supported several types of BMS controller protocols and had quite a few more settings. But I think Growatt really don't want you to use this with a third-party battery or third-party BMS. And presumably they think they want to make all their money and don't want you to use third-party battery packs, or lithium ones at least. So that language, the protocol, the actual codes and structure of the instructions and the responses aren't freely available on the web, and I don't think they will disclose it. I've kind of asked because I am a licensed reseller, but yeah, so I don't want to mess up my opportunity with them, but they can't supply me batteries, but I can get their inverters, so what am I going to do? So, and then going over to here, we've got the same interface on here. Look, we've got the BMS, and we've got a little socket down there. There's some sockets underneath. One of them's a CAN bus socket, and I'd like to get this talking to that so that I can see this reporting to that, controlling that. That will then give me an accurate state of charge of the batteries, and I can look at everything through the Shine interface, which is the utility on your phone or on your computer, which allows you to interrogate this. And we'll go into that in a different video because there's quite a lot to cover on this inverter. So that's the issue I've got, and I'll show you what I've done in the meantime so that I can use it. I've set this to lead acid mode, and when you go into the basic setups, you can go into lead acid mode using the navigation keys, and the lead acid mode asks you 3 settings. It says, what's your charge voltage, what charge current do you want between 5 and 60 amps, and what's your low voltage. Your low voltage being if the voltage of the terminals reaches this voltage when you're discharging, do not discharge any further. Alright, so by setting those up, by doing the calculations of the parameters that we want on these cells, 14 times 3.6 or 4.2, we can set the maximum voltage OK, we can set the minimum voltage OK, and this won't indicate the power properly because the charge versus terminal voltage under load characteristics of the lithium ion are different to lead acid. So this will give an intrinsically sort of inaccurate reading, but that's not such a problem providing the batteries are charging safely, okay, because you can only put so much into the battery, you can only take so much out. Now what we have here is the same ability here to set up the thing to, if, as I said, any battery goes above a certain voltage which you specify, the 150 amp FET switch will open, so no further dangerous charging or discharging can happen because this will be connected, and this will auto recover. If you disconnect the battery, it'll just go into the fault mode, or start lighting, start flashing on the fault, and when the battery voltage comes back, it will automatically recover. So switching this off isn't an issue. So the only real issue I can think is that in the 4 hours of my reduced tariff electricity, I want to put the full 10 kilowatts into this, then I'm going to have to charge 40-50 amps, something like that. And I do not know whether this has a 3-stage lead acid battery charging circuit or not method. Normally you would provide the bulk charge as constant current, and then when you get to 14.2 volts on a 12 volt car battery, for example, or thereabouts, you would switch to 14.4 volt constant voltage and trickle in that last 5% of the charge. These do not like, once you get to 4.2 volts, you can go constant current up to 1C, so these with 95, so you could put a 95 amp charge in one of these cells if you wanted to, or 180 amps for the whole battery for a rapid charge. I'm not going to do anything like that because I've got much longer to charge than a car would normally have. And when you get to 4.2 volts on these batteries, you're supposed to switch to a constant voltage mode and not drive any more current in. If you drive in more current at that voltage than specified, then you'll damage the battery, you'll etch the plates and they'll overheat and they'll start fizzing and it'll blow its bag at you. So I haven't actually, it's been working, it's been cycling, it's been using. I've been running the air conditioning on it up there because it's been really hot. So that's about 1.8 kilowatts, and I'll just charge this up overnight and bring the feed for the air conditioner up here and plug into that thing at the back, and it runs my air conditioning in the office, up here in the office. Well, office studio. That's my 12-track tape recorder. Lovely. Anyway, yeah, so I've run it and it seems to work fine. It will cut out, it can't be damaged, but I've yet to map the charge method in lead acid mode. But the ultimate plan, I've got this CAN bus sniffer we use for development. It's called a CAN do, and you put it on the CAN bus and then earwig, and I can see all the traffic. And what I'll do first is I will go downstairs to my Growatts, connect this up, and then record all their conversations, and then try and debug the Growatt protocol. Then this protocol is published. I think I can get that from the from Jikong, in which case I just need to make a small AVR processor board as a translator. This will ask its question in Growatt language, and this will receive it in Jikong language, and the exchanges, I hope, can be made so that I can just stick that in lithium mode, let it do its thing with this, communicate with that, and then on the Growatt interface, web interface, I can see the state of charge. Then I don't even need to look at it anymore. At the moment I'm looking at it on a sort of a daily basis just to check the voltage and see what's been happening during the night. So that's where we're at. with the Jikong and the Mercedes batteries. The next step, I've got another one of these battery packs downstairs. I think I'm right in saying, if you know different, let me know, that they have to be horizontal because of this witness blister thingy bob. And there is some information, but I can't work it out, so I'm not going to take any risks, and I'm just going to mount them horizontally. So I'm going to set a spacers and the other pack on top or underneath this one, but with the balancer for the one underneath on the board as well. And clearly I think the battery leads, once I check that they're all in the same state of charge, I will just connect the battery leads. I'll just loop them in parallel with each other. Alright, so I hope you found that interesting. If you did, then subscribe down there by the titty button if you're not subscribed, and if you are subscribed, thank you, and leave me a like, and I'll see you in part 3. Oh, and the instruction, the full instruction manual for this thing, which I couldn't get hold of, is in, I'll put it in the comments section. I'll upload it to the web and I'll put it in the comments section so you can actually see quite a bit more information on that box, because all you get with it is this, which really frankly is pretty inadequate. Had me going for a while for certainly guessing what's supposed to be going on. Anyway, that's that. Hope you enjoyed it. Take care. See you next time.